Hi, this is Tom, amateur radio call sign November 8, Foxtrot Delta Yankee. And today it's time for another meter review. And this starts our series of the under $100 meters. And the first meter we're going to review, I bought off of eBay. It did not come in a box. They shoved it in a shipping package, and when I got it, this was it. So this is the ANENG AN870. And I'm starting with this one because out of the bunch, I believe this is the best one. So you already know I like it as far as I can like a meter that is not third-party safety tested, because you know that's one of my big criterias. But I realize that many people do not want to pay that extra price. And that's why I'm doing this series of under $100 meters, so that people who need to spend less but still want a halfway decent meter can get one. And this one, I think I paid about $64 for it, but it is down to around $47. I checked on eBay recently. That is the only way you can get this meter is on eBay. At least that's the only way I've found. But anyway, it's a 10,000 count meter, and that's not bad, and it has a DC accuracy of 0.05%, which in this group of meters is the most accurately specified meter. And in most cases, it meets most of its accuracy specifications. There were a couple of misses, which I'll go over in the details, but in general, it's a pretty accurate meter for the price. For under $50, this is at least this copy of the meter is very sticks to its specifications, except in two small instances. It comes with a set of leads, which are, of course, plasticky and not gold plated. They have the Cat 4 protectors, which in this meter's case, I would never use this meter in a Cat 3 or 4 environment, but that's just my opinion. It says it's marked with Cat 3 and Cat 4, but you notice it's marked with a CE mark. Now, I know our friends in Europe go by that, and that's great. And you have to have that to sell anything in the EU, but it is a self-enforced, self-tested. So I don't really have much faith in that. But then, what do I know? So anyway, I don't think you're going to buy. If you need to only spend $50 for a meter, you're not going to spend $40 for a set of good probes. So these, they're typical of this price meter, so it's no problem. I mean, I wouldn't use them, but, I would. For myself, I wouldn't buy this meter, but everybody has different priorities. My priority is accuracy, reliability, and convenience. And price isn't even in the equation, but many people can't afford to do that. So it also comes with these strange little leads that, again, are plasticky, but still, it's a second set of leads. But if you notice, they don't have any connections on them. Everything is screwed in separately. So if you want to use this, you have to screw it in and unscrew it. If you want to plug it into the meter, you got to go find the banana plug here and screw it in. And if you want to use alligator clips, you got to screw those in. And you could actually put alligator clips on both sides, because they give you 4 alligator clips. Anyway, it's an odd little test lead set that they throw in, but you know, remember, you get what you pay for, so I'll just set those over here. We will test the continuity with our probe masters, even though I know you probably won't use probe masters on this meter. It does come with a written manual, and it is in a couple of different languages, so the manual doesn't cover as much as you think it does by its size, because it has a number of languages, but it gives you the essential information. And it comes with a little soft case that is probably the cheapest soft case you could get that still doesn't have holes in it. So, you know, it's all right, but remember, this is only, like I said, you can get it for about 40, 47, 42. Let me check. The details are in the written review, which is the link in the description. I do like to have the written review have all the details, because I'm sure I'm going to forget some things, and I don't have really the way to go delve in deep as I do on the written review. But anyway, on the written review, it says I paid $60.46 for this on eBay, and but as of October 23rd, I saw it for $42.29. And that was from the store Beautiful 003. So hopefully they still have that sale. And you know, for $43, you can't beat this meter. 10,000 count. Anyway, I thought I'd just look that up. I always have my notes here because I forget stuff and gotta look stuff up. Let's get to the features of this meter. This is a 20,000 count meter. Excuse me. I thought it was a 10,000 count meter for that price. It has a basic DC accuracy of 0.05% plus or minus 3. It's a true RMS meter. Has a data hold function. Has a delta or relative function. Has a min-max function. It has an NCV, which is non-contact voltage detection. And it has a 1-year warranty. So for $43, you can't beat that. So again, to correct my mistake at the beginning of the video, this is a 20,000 count meter. So let's take a look at how she works. The only thing we can do is override the auto power off. So we're going to do that by holding the select button down and turning it on. Turn on the backlight and it'll turn off in a few minutes. So that's just the way it works. Since it's been a while since I've reviewed meters, and since this is a different class of meter, it's a medium count, low cost meter, so it's, like I said, 20,000 count, it's $43. I've also upgraded my test equipment. I now have a 10 volt reference that is highly accurate, and I now have the latest version of DMM check, which has been upgraded, and of course these have been calibrated a lot more recently than my older ones, so I'm going to go with these because it is the most accurate voltage standard I have in the house, so I like it. This 10 volt reference is read as 10.006, and let me tell you, that's very good for a $43 meter. And we get 5.002. Again, that's pretty good. Okay. Now we're going to use my little digital analog converter to spew out some voltages, give you an idea how this meter works. Again, this will be in the written review so you can see what the source voltage actually is on my Keithley compared to this, but for this demonstration we're just going to go with what we got. And just as a disclaimer, this is less accurate on the lower voltages because it's really hard to, on a 16-bit DAC, to get accurate when you're down in the millivolt range. So But anyway, as you can see, this hits the millivolt fine. Then that's 5 millivolts, 10 millivolts, there's 25, there's 50, and you see the light has gone out a while ago. So turn the light back on, but it'll go off in a little bit. And it's just that's pretty much the most annoying thing about this meter is you can't make the light stay on. 100. Oops. All right. So that's an interesting thing you'll see in the written review, that really you can't go over 200 millivolts on this guy. And the next above this is 250. So you got to switch it over to the voltage range. So now you see that 100 millivolts is 0.1001 volts. And now we go to 250 millivolts, which is 0.2501 volts. And there's the 500 millivolts, which is 0.5001 volts. So it's pretty close. And there's 1 volt. It's 1.002. So again, that's pretty good. Remember, this is a $43 meter. There's 1.5 volts. And there's your 2 volts. Now, again, the stack just is not too accurate, the 2.5 volt range, because that's right where its reference level is. So, well, pretty good today. Anyway, there's your DC volts. And in the written review, you'll see all the stuff. And let's just go over the highlights of that now. Well, with the DC voltage, as you can see, it's 0.005% plus or minus 3 on all the DC voltage range. So that's pretty good. Very consistent. And as you can see here, on the voltages I can show you on the summary, it met the specifications. Now, that I'll have to tell you that it isn't listed here, but it is in the written review. The 15 volt mark was about 3 millivolts off from its specification, which really isn't that bad. I mean, for a $43 meter, it's fantastic, but it was off on the 15 volt reading. I don't know why. I did the reading a number of times, and it was always just a tiny bit off. So I don't know what the deal is, but I'm not going to hold it against this meter. The input impedance was 11 mega ohms on the voltage range, and on the millivolt range it was 10 mega ohms. So that's not bad. Now we'll talk a little bit about the AC voltage. It reads 4.972, which is pretty close to the 5 volts. And we'll check the frequency again, and the frequency says it's 99.99 hertz. So this is a 99 hertz, almost, well, 100 hertz square wave. And, you know, it reads really close to 5 volts. So, again, like I said, maybe up to 400 hertz, it'll be fine, true RMS. But now the 100 hertz square wave I showed you, it says it's 0.3% plus or minus 3. And on the bench, it was a little low. It read 4972. And based on the specs, the lowest it should have read was 4975. So again, it's 3 millivolts low. For a $43 meter, that's fine. And like I said, but all the other readings met specifications. And there's even more readings in the written review. And the frequency response was 3 kilohertz. So it was down 3 dBs at 3 kilohertz. So again, that's not very much AC bandwidth. So you're not going to do audio measurements with this meter. Okay, let's try some current. Here's our microamp scale, and we're 0.89 microamps, and this does it as 0.91. 0.9. Very good. Here's 9.21 milliamps, and we get 9.22. Pretty good. Here's 99 microamps, and we get 99.02. Here's 131.8 microamps, and we get 131.91. Still pretty close. Remember, this is a $43 meter here. Now we're going to go up to the milliamp range. Here's 1.0 milliamps, and we get 1.01. 1. Yeah, there goes the light again. 1.01. Oh, now. Oh, well, that's going to back and forth. But still, $43 meter. Here's 9.98 milliamps, and it rounds it up to 10. That's still pretty good. 99.4 milliamps, and it's 99.52. Still pretty good. Well, let's look at what we measured on the bench. AC current, and the milliamp range is 0.8% plus or minus 3, so that met the specifications. The DC microamps, milliamps, and amps were all 0.5% plus or minus 3. And all the measurements I made met the accuracy specifications. So there's more details in the written review, but this was pretty good. Now the shunt resistance was 0.1 ohm for the amp shunt and 2.78 ohms for the milliamp, and 101.62 for the microamps. That's very typical of most of the meters. So it's not radically different than anything else. Let's talk about the accuracy specifications for the volts and amps. Well, this group of meters, which is my under $100 meters, and you can see that most of them are under 50. This one definitely had the best specifications in the millivolts and volts for DC, and the DC microamps, milliamps, and amps. And for the AC milliamps and amps, this meter had the best specifications. So I would say out of this group of meters, if you're okay with the features, this would be my first choice out of this group. My second choice would be the Thucyndi 18Z-3, because it's even cheaper and it's very close in specification. The only problem with it is I can't find one anymore. I bought one a while ago for $40, and I searched and searched around the last couple of days, and I can't find that guy anywhere. So I don't even know if I should review it since you can't buy it anymore. But maybe if you buy it in a flea market or Hamfest, you might find one. So I will. I think I'm going to review it. But of the ones I know you can buy, this one is the one that has the best accuracy specifications in it, except in those couple exceptions we talked about. It meets its accuracy. All right, we have leads that have internal resistance. So we are going to use the rel function or the delta function to fix this problem. And that's this key right here. Let's rel them out. All right. Still a little tiny bit of noise that it picks up this, but you can't really do much about that. So let's start with the 1.004 ohm resistor. And we get 1.13. So That's pretty close. Now we're going to do the 10.007 resistor. Well, 10.23. 100.069, and we get 100. There goes the light again. We get 100.25. Here's a 1.0001 kilo ohm resistor, and like most meters, when you have it in the relative mode, it can't auto range. So I have to take it out of relative mode, and we get 1.0007. That's pretty good. So it looks like it does a little better in the higher ohm ranges. Here's 10.002 kilo ohms, and we get 9.998. Okay. Here's 100.02 kilo ohms. 103. So that's pretty close. 0.997, and we get 0.994. That's okay. Here's 9.97 kilo ohms, and we get 9.96. Yeah, it's starting to get a little jumpy on this high mega ohm range because of random noise. Here's 100 mega ohms. And, well, it's even more jumpy at 100 megs, but it reads it. So 99.7, we'll give it that. That's pretty close. Well, this is the cheapest meter I've ever seen that could run, could actually measure 100 mega ohms. So that's actually okay, because a lot of meters that cost more than this can't do 100 meg. They stop at a lower range. But this is interesting because we're 100 meg. Well, let's show you what the test results in the bench were. For the lower ohm range, it's 0.5% plus 3, plus or minus 3. It met those specifications. Now at the kilo ohm range, it's 0.2% plus or minus 3, and it met those specifications. Now at the mega ohm ranges, the specifications definitely go down. The 1% plus 3 for the 1 and 10 mega ohm range, and then it's 5% plus 5 for the 100 meg. So we can do 100 mega ohms, but it's, pretty less accurate. But hey, this is pretty good for a $43 meter. Now the voltages it used was, for the low range, it used 1.03 volts. In the medium ranges, it used 0.93 volts. And in the high range, it used 0.51 volts. Now let's go to capacitance. All right. Usually we try to zero the stray capacitance, but this can't read any stray capacitance, so we won't use the delta function to fix that because it doesn't show anything. It's a little suspicious, but what are you going to do? Well, again, like many of my reviews, I'm skipping these two low-end picofarad guys because most meters just can't deal with that. It's just too low. So we're going to start out with the 1 nanofarad, 1.005. So 1.005, and we get 1.012. Pretty close. Most meters that use this charge-discharge cycle to measure capacitance are the most accurate with film capacitors. And that's what these 4 capacitors here are, film capacitors. So these ceramic capacitors are not, this charge-discharge cycle, I guess, doesn't work that well. And with electrolytics, it doesn't work as well as with the film. So that's, I think, why you'll see the best performance on these film capacitors. Here's 9.921 nanofarads, and we get 9.985. Oh, there goes the light. Here's 99.51 nanofarads. 99.77. That's pretty good. Here's 1.009 microfarads. We get 1.005. That's still pretty good. All right, now we're going in the electrolytics, so things may not be as wonderful. Here's 10.294, and we get 11.12. I'd say for electrolytic, that's pretty good. Here's 112.2, and we get 113.8. Pretty close for an electrolytic. Here's 994.5. Okay. They switched to millifarads, which I'm not too crazy about meters doing that, but most of them do it nowadays. But that's pretty close. I mean, it's a little further away, but again, your high-value electrolytic, at least in my view, I know there's a lot higher value electrolytics, but I've never found a use for them. Let's take a look at the bench measurements and see how the accuracy worked out. The nanofarad range, at least with the 1 and 10 nanofarads, it's in 5% plus or minus 20. So that's pretty wide spec, but it met that, and as we've seen in practice, it was pretty close. 100 nanofarad, it's 2% plus 5. The microfarads, at least the lower ones, were 2% plus 5, and then the higher end was 5% plus 5. So it met all the specifications for that. Let's go over the accuracy specifications for the resistance and capacitance. Well, as you can see, this meter had the best accuracy specifications for the low kiloohm and high kiloohm range, and for the high nanofarad and low and high microfarad ranges. Again, it had lots of 5 ranges where it's the best in accuracy specification, and it met all its accuracy specs in all the readings I took. I'd say the second best meter in that regard would be, well, you got the Zotac ZTY, and you got the Cindy 18Z-3, but we know that guy's not available. And he had the worst accuracy specification in the high microfarad. So, I'd say you're still pretty good doing with this ANENG AN870s. Probably out of this group of meters, the best bang for your buck there. Well, it's diode test time. Well, this meter does not chirp when it tests diodes, at least not with LEDs. But it lights it pretty good. Lights that one pretty good. Green one, it's a little dimmer, but that's usually what happens with the green one, so that's okay too. Now, I used to kind of say, well, who cares if it can test LEDs or not? But I'll tell you what happened to me once. I try to include LEDs as power indicators because a lot of my boards, I have the power regulator on board. And it's a really easy check to use an LED to make sure the power regulator is working when you bring it up. And I bought from reputable dealer, I bought 100 green LEDs and 100 red ones. And usually most of the green ones is the power indicators because, if it's the green one's on, everything's good. And you just adjust the resistors. So some boards I have plus 12 volts, minus 12 volts, 5 volts, and 3 volts, 3.3 volts. So I got 4 LEDs, 4 green LEDs on the board, 1 for each of the regulators. And it really works out, it's really convenient. Well, one day, I brought up a board and one of the LEDs didn't come up. So I said, bad regulator. So I'm testing and everything's fine. The voltage is there. And I go, and it was a bad LED. I've never had a bad LED, never even thought about it. And it was a pain in the butt to unsolder that LED and solder in a new one. Because I use through holes, even though a lot of this stuff I use now is surface mount, I still like the through hole well, like I said, I bought 100 of them, so I'm not buying any other LEDs till I use those up. So now I do test LEDs before I solder them in, because I don't want to get this false negative that my regulator's bad. So I now have a better appreciation for testing LEDs with your multimeter, because it is handy, and if that'll keep you from having to unsolder a bad one, it's worth doing. So you know, I was a little flippant about testing LEDs with this, but now I realize appreciate the value of it. So let's go to regular diodes. All right, here's a Schottky diode. That works. Again, no chirping. Now, why is a Schottky diode so wonderful? Well, because the forward voltage drop is really low, and sometimes that's important. Another tidbit I learned since I've been having a break from testing meters, and I just picked this up, I don't know, a month ago, maybe 2 months ago. I don't know if you guys ever follow Lady Ada. She owns Adafruit, and they have a newsletter they send out that you can get, and she has some YouTube videos she does every week. But anyway, she gives some interesting technical tidbits, and one of her tidbit was, you know, this a digital multimeter is great for testing diodes, but it isn't really accurate on the forward voltage. I mean, it does show the forward voltage, and you know, many meters will agree, but the voltage it used to test those is so low that it really isn't really, and the current it uses is so low that it really doesn't show what the diode does in normal circumstances. And you need like a curve tracer to do that. But anyway, she was saying that in real life circuits, the voltage drop is different than what this meter will show, because this uses such low voltage and current. And I never thought of that. I should have thought of that but I never did. Never even dawned on me. So, you know, if you're into microcontrollers and maker projects and that kind of stuff, you ought to give Adafruit a try. They have, besides their store website, they have a Learn website, which covers a lot of their products and guides for different projects. And sign up for their newsletter if you, well, I use CircuitPython in my microprocessor stuff that isn't time critical. And she has a lot of tidbits about that. So anyway, I'll put a link to her site. Here's a small signal diode. Again, no chirps. And here is a power diode. Again, no chirps. Well, speaking of test voltages and test currents for the diodes, let's see what this meter used. Well, the test voltage was 3.25 volts, and the maximum current was 1.86 milliamps. And that's pretty good for a $42 meter. This meter also does temperature measurements, but they don't include a thermocouple. You're going to have to get your own. I didn't test that. I don't really have an accurate temperature source. And I know people have told me, oh, you put some ice in the ice water. Well, I talked to a guy who used to do measurements testing, and he worked for a company that made test equipment for telephone companies. And he said that it's not that simple as putting ice in water, because I was talking to him about how to accurately measure thermometers. And he said, oh, no, you need a special slurry that's made of these certain chemicals and this and that. And because he says barometric pressure affects the freezing point. And he says it's a lot more complicated than you think. So really the only way I've seen that you can test accuracy of thermometers is you're going to have to buy a calibrated thermometer. And I looked how much those cost, and I'm going, nah, I don't need that. Well, let's do some continuity checks. Now, to be fair to all the meters, I use the same test leads. I know that you're not going to use these test leads if you buy this meter. But I want to be fair to all the meters so they aren't penalized by the test leads that come with them to test continuity. The probe masters don't fit. You can't push them down. I don't know why. That's kind of weird, but you can't. So they'll well, see, they just fall right out. So, but they do make contact. So we're still going to use them. Let's see. Yeah, they still make contact. So, but in practice, they wouldn't be a good fit for this. So, but you wouldn't buy probe masters that cost about as much as the meter does. That just wouldn't make sense. So anyway, we're going to test it. You see that delay? I know it may be hard to see that, but you touch it and we'll let it go. And it still beeps. So touch, off, off. See, there's a delay. So watch what happens. So it's really not good for fast continuity checking. It's okay for slow, but you see that delay. So, it'll do for basic continuity checking, but for what a lot of people do, it probably won't. Let's talk about the battery. This uses a boot, and it's pretty tough. You gotta kind of open this, kind of push that out, you know, if you want to get that off. Now, you don't really need to get it off to get to the battery, but if you want to get to the fuses, you got to get it off. So anyway, one screw, and it's not captured, but luckily I didn't lose it. 2 AA's. But if you need to get to the fuses, you got to take these other screws out, and they're not captured, and they go into plastic. So when you put it back together, be really careful. You don't want to damage the plastic. You know, if you're going to put screws back in, self-tapping screws back into plastic, remember to back them a little bit out so you hear that click, and then try to catch the same groove so you don't try to cut a new one. Now we can go to the pros and cons. There's 3 major pros to this meter. It has high basic DC accuracy, 0.05% plus or minus 3, and that is the highest in this group of $100 meters. And that is pretty impressive. It had the best accuracy specifications in 12 out of the 19 ranges in this group of meters. Again, pretty impressive. So I'd say it has a good value for the price. Now we get to the cons. Well, it's not third-party safety tested. Yeah, I know, it's got a CE mark, but that's self-tested. And, you know, some companies are reputable, so you can trust that. Other companies, I don't know. You know, the EU thinks that's a great system, and they require that for any product sold in the EU, so I'm not going to argue with them, but I would much rather use a meter that has a CSA, ETL, or UL, third-party safety tested mark on it. Now, okay, I'm going to admit it. I do use the Hioki, and I like the Hioki, and it does not have any of that on it. So, so I guess call me a hypocrite, but I would never use the Hioki in any Category 3 or Category 4 measurements. I strictly use it for, in my case, I use it for audio measurements because it's really nice for that. And but if I'm going to do any of that other stuff, I stick to my tested meters. The fuses are only rated to 250 volt, 600 volts Category 4. It says it right on the meter. But how can I believe that when the fuses are only rated at 250 volts. It just is nonsensical. And any third-party safety tested meter, you'll find that the fuses are rated at 1,000 volts. So, and they're different looking fuses. They're, what do they call those? Oh, I can't remember, but they're rupture proof or something like that. And these look like normal fuses. You have to disassemble the meter to change the fuses. Now we get to the DC voltage reading at 15 volts was above the specified level by 3 millivolts. So 3 millivolts for $43, that's okay. The 5 volt AC 100 hertz square wave reading was low by 3 millivolts to the specification. But again, $43 meter, it's okay. It's unclear where to get the warranty service. It's nice that it says it's a 1-year warranty, but it's really unclear who makes this meter and where you can get it. This meter looks very similar to other meters with different manufacturer names on it. So it's only available on eBay. I admit I've bought a lot of stuff from eBay, but that definitely is not a way to predict reliable prices or availability, because you gotta shop around, and like the store I bought this from doesn't even sell meters anymore, and the new store I never heard of before. But the screen's readable. The switch is pretty tight, so you don't get stuck in the middle. The beeping every time you switch it is annoying, but that's how these economical meters are. All of them are like that. They all beep. All the ranges that hobbyists want, and it'll measure temperature, but you have to buy your own thermocouple. It runs on batteries, two AA's, which are easy to find. Not like, a lot of people don't like the 9 volts. I guess in many countries, 9 volts are not very available. So all around, it's, if you don't mind buying stuff off of eBay and having a nebulous warranty that you don't know how you can get it taken care of, if you only got $50, this is the meter. At least the one I've found. You can buy there's lots of meters under $50, but if you are interested in more accuracy, this one, at least this particular one, tested pretty good. I hope that helps you. I know a lot of my followers are into the higher end meters, and I appreciate that because that's what I'm into. But I realize that especially beginners who don't really know if electronics is what they really want to do or not, but they want to dabble with it, they need a low-cost, entry-level way to start measuring voltage, resistance, capacitance, current. And this is the way to do it. Anyway, thanks for watching. This is Tom, N8FDY, saying 73, and take it easy.